Hey, thank you, Dr. Ashwati. Thank you, everyone. Very good evening to one and all. Hope I am audible. So, if any one of you can confirm, confirm
Yes,
it.
sir.
Yeah,
Audible, sir.
all right,
Yes, sir.
great. Again, I was not assigned to this FTP initially, but one of our colleagues, you might have seen his name over there in the notice and all. So he's not available for the day today because he's actually sick. So that's what I have joined for the first session, and as Dr. Ashwati mentioned, so we'll have the second session, second phase by Deepasree Varma, right? As assigned, I'll be sharing my screen. So in case of any doubts or further discussions required, probably will be paused. Otherwise, we can continue with the discussions. So again, as the moderator mentioned, for the day two, we have to have a discussion on what is actually CI/CD, what is the relevance of CI/CD at this point in time, especially while we are thinking about MLOps, ML-enabled applications and all. Based on our experience and the projects what we have completed so far, I'll be talking on that perspective, and probably once we are into it, probably the demonstration will be completed, will be done by Deepasree. Let me share the screen for a second. I'm just switching off my video to manage the data bandwidth at this point in time. But let us continue to discuss. I'll come back during the Q&A. So I'm sharing my screen. One of you can confirm if it is okay. Yeah, it is loaded, right?
Yes, sir. Visible.
So yeah. As Dr. Shruti mentioned, yesterday we had a discussion about the ML life cycle, basics of ML. Today, let us move into the engineering discipline of ML. So, in the center, the core idea at this point in time is a model is not production ready because it works once. See, we could not say that the model is what is a model. I think you might have an orientation, or you might have an idea about the model at this point in time. But what we are coming to say here is a model is not at all fully functional because it is. We may have to have an interventions whenever there is a requirement. So why we are saying so here is, you may be knowing that the model once deployed, we may have to have continuous interventions to improve that particular model. Because in a machine learning model, we know that whenever data changes, whenever parameter tuning required, whenever any smart drifting happens, or anything such things happen, right? We may have to intervene again and again to deal with the model fine tuning. So, especially in this case, in this area, we know that see, will have to explore the model of automation, CI/CD, all those details, right? So, why machine learning needs automated pipelines is the requirement may have to discuss at this point in time. So, let me start with a simple statement. Building a model is easy. Maintaining a model is engineering. In our traffic accident, we had an opportunity to develop one of the applications for one of traffic severity prediction system for one of the government organizations. This was actually, this was actually helpful for us to understand the requirements based on the model fine tuning, model so how to retrain the model. All those details were there in it. In our accident severity prediction system, the model initially performed extremely well. That means above 90%. But after a few months, accuracy started dropping. So, any suggestions? Any why it may be? Because say that accident prediction systems are readily disconnected with our maybe road conditions, traffic patterns, maybe seasonal factors like rain, maybe our local celebrations, etc. So, if a retraining is manual, that means there is a change in the source data itself, right? So, if a retraining is manual, it becomes inconsistent. Automation is not a luxury at this point in time. We should say that it is a matter of survival. So again, the reality of ML in production. So how this behaves, the production, in the sense, whenever if you are thinking about an application which has been hosted in any of the production servers, right? So then we may have to say that this is all about it is up and running. Either it can be a scalable application, or it may be any one of the recently developed projects or anything, right? So if it is in a production environment, it may not be. If it is a simple application, again, it is if it is not a machine learning enabled applications, we don't want it to have that much worry, because in case of any updates comes in, or in case of any changes required, especially in the rule, we have to have a second thought, right, about the updates. But in the machine learning model, right, so once a model go live, three things happen. First thing, model may degrade. Second, the data shifts. Because of the data shifts, the predictions and everything will be different. Third one is manual retraining introduces risk. Sorry. Why we are saying so here is manual retraining may be sometimes required, right? In our enforcement analytical system, right? So the festival season drastically changed the violation patterns itself. The model trained on normal weeks began mispredicting hotspot. That means the hotspot prediction was actually maybe different, right? You may be knowing that the traffic in weekdays and the weekends are different, right? In holidays are different. So all those details may have to be taken into account while we are developing a model. So see, what is the speciality of such situations are, it may not be noticed very immediately. That is the real danger, because whenever if you are dealing with a machine learning prediction enabled systems, right, we have to say that the model is running perfectly. Moreover, the silent degradation also needs to be addressed or planned. So, see, this is the familiar figure we might have, right? So, it may be we might have already discussed. Say again, see, these are not, again, it is not linear at this point in time. So we know that data, reprocessing, training, deployment, monitoring, and retraining. Most failures occurs not inside stages, but between stages. Automation targets the transitions, not just computation. So why we are saying so is the between stages, the communication again. If there is a change in the spec, the pre-processing is not performed, so the model interpretation will change. So that also needs to be addressed while we are trying to deploy a machine learning model. So see, what are the challenges without automation? What are the challenges if we are approaching, let us plan to have an approach to deploy an application in the same manner, maybe in the manual workflow as we did for some traditional or standalone web applications or so. So, what are the challenges at this point in time, right? If a training is manual, results are not reproduced, right? Again, results are also important because whenever there is a data flow, a retraining happens, we have to have a mechanism to say mention that what are results generated so far that is stable enough and which sticks on, right? If there is no data validation, corrupted data corrupted data poisons the model, right? If deployment is maybe in right based on our experience, right? We have trained the model with updated district boundary shape files, right? If it is a project which is maybe some maths or geometrical information involved, right? We were assigned with the responsibility to develop maybe to identify a particular circle. Either it can be a district circle. We might have we'll be loading all the shape files into it, but the production still use the old shape files means our remapping facilities will be different in that case. So hotspot clusters were misaligned, and we couldn't reproduce the issue easily. That is what the lack of automation does. Right. So in case of the reproducibility problem comes in, this issue is very a common issue. Model trains perfectly on developer's machine fails in production. Why? So maybe let us assume that there is a version, Python version is different, missing any dependency, right? Say version drift, right? We once faced this when deploying a GPU-based model on a DigitalOcean server. Local environment worked, but production did not. This is not a model issue. It is really an environment-related issue. So again, what we can plan at this point in time is, say data and model versioning is also important. So the version code, as we might have seen yesterday, right? But ML requires more. Again, we are not at all dealing with the code, but data, the training data, maybe validating data, all that life cycle is important for us. We must have a version of code, data set snapshot, model artifact, right? Then hyperparameters in our enforcement data set and all. Schema changed year to year, right? If you don't have a version of our data properly, reproducibility disappears, right? Again, most of the negative talks regarding this is the version maybe again, which is a black box, right? The core logic is a black box. So that should be identified. That should be effectively we may have to manage, right? So yeah, again, the data artifact at this point in time, the management of data model artifact and everything else is important at this point in time. So keep automated models, right? Automated models in the sense, yeah. Keep models fresh in this case. Our JIT versions code, but ML requires most. These are the things we have mentioned, right? In our automated retraining pipeline, right? Say a model must retrain when a data drift is detected, performance threshold drops, right? So again, maybe model metrics fall below the target. let us assume that we have fixed an accuracy of some 90%. There is a reduction in it, then we may have to manage it, right? A scheduled interval occurs, right? Maybe a particular periodic retraining is requires, right? One example during in our the example what I have mentioned regarding the traffic and enforcement data management during monsoon season, the road friction changes, accident severity also, which is directly proportional or depends on the accident severity prediction. If training is not triggered automatically, predictions become inaccurate. Continuous training is a part of ML's maturity. So again, so let us think about an automated ML pipeline here. An automated ML pipeline orchestrates everything here, right? So the push code, validate your data, train, evaluate, and the store the model, and let us go for deployment as well. See, the primary aim at this point in time is we are not at all talking about developing a model, but how we can maintain that particular model, machine learning model, through its continuous, by assuring its continuous learning process. So in each stage, we have to assure that it is logged. Each stage has quality gates. Each stage is auditable. This is how the ML becomes engineering, right? So in see, if you think about the ML benefits automation, in the automation, it is not optional here, right? It is, we should say that it is essential, because this is important. Automation is not something we add later. It must begin from the prototype stage. Version everything, monitor continuously. If we do not teach automation, we produce we produce just data scientists, not ML engineers. So that is the again maybe maybe an understanding regarding our data scientists and the ML engineers, the role of data scientists and the ML engineers here, right? So again, if you think about the benefits, right? Automation provides reliability, reproducibility, faster iteration, and governance. For public sector projects, governance and audibility are critical. See, you must be able to answer which model was deployed, with which data at what time. So, so these all are the basic details we may have to maintain while we are dealing with or while we are trying to deploy a machine learning model. See, here, let us, with this base, maybe foundation of ML automation, the requirement of ML automation, let us just move to the foundations that is required to have our maybe CI and CD foundations, which is required to evolution of ML CI CD. So, CI/CD is the backbone of modern software engineering, because nobody can sit in front of the machine as per the requirement. Whenever there is a release, whenever there is a version controlling, version change is there, then we may have to sit and manage all those details. It is different, because again, at this point in time, we should say that CI/CD foundations are the backbone. ML borrows this discipline, but ML extends it further, right? So, see, with this, let us just move into the stage of what is all about continuous integration. Continuous integration is the practice of automatically integrating the code, right? Every code push triggers, build, test, and validate, right? We know that there is a requirement, especially dealing with our continuous integration. Why continuous integration is required? Whenever if you are dealing with an application, right, that can be used for the deployment, in that case, we have to assure that there is a build. We have to the test, right? So the model, maybe the accuracy check of the model, that needs to be assured here, right? In our accident, maybe enforcement pipeline, in a feature engineering change removes a column accidentally, right? So continuous integration catches it immediately. That is discipline, right? If anything went wrong in any of the stages, right? Either it is in the pre-processing stage or in data collection, maybe, or in any of the stages, right? So that will be automatically, we'll get an alert and we can, right? So just instead of ignoring that particular column or feature, if we can have a mechanism to check that what is all about, how we can say improve this further, that mechanism should be there. We should say that continuous integration, again, this will be a discipline. What is all about continuous deployment, right? Continuous deployment in the sense, once validated, code moves to staging or production server automatically. So we know that there is a best practice of moving the application once it is developed from check it in the staging server before moving it into the production environment. So once validated, we have to assure that we have moved everything into the required space. Manual deployments introduce human error, right? Especially, which is especially dangerous in machine learning environment. So continuous deployment is continuous integration is required for us to make it sure that everything is intact. Continuous deployment is to make it sure that there are no further errors, because let's assume that if you are dealing with the production environment and all, right, if any errors happens in between, right, it may lead to down the system, right? So it will badly affect the availability of the system as well. So that needs to be checked, and we have to assure that there is no such errors happen. So let us think about a traditional CI/CD flow. What happens in a traditional CI/CD flow, right? Let us assume that we have created a web application. What happens normally, right? We will release cycles, bug discovery time, but the human errors also will be there, right? We know that how it will happen. We'll the code commit will be there, then build package, automated test, maybe staging and deploy. If this is the flow, there is actually a possibility of, if you are trying to have our release cycle, bug discovery time, and human error. For ML dashboards used in the project what we have mentioned, right? Reliability is not negotiable, because ML applications are very common, right? Any non-availability of that application, which is actually badly affect the credibility of that particular application. Again, being an ML engineer or a model developer, right? We have to have an assurance. We have to make an assurance that the system what we have developed is available, right? Maybe the available, scalable, the security also matters. All those details we have to assure, right? So why CI/CD matters here, right? So CI/CD matters in the sense the traditional flow is linear: commit, build, test, deploy, right? So then we can have a deterministic option here. Binary kind of an information will be available, like pass or fail. But ML is different, right? ML ML is different means, right? Where the false shortfall for ML, ML introduces complexity. There is introduces complexity. Data is a first-class artifact for any ML project. Output are non-deterministic, right? So we maybe whatever may be the type of model what we have used so far, it may not be sufficient enough. It may not be we may not be knowing about the results, right? A deployment depends on performance metrics, right? So evaluation of our model again, the deploy performance based on the performance of the model, right? We may have to maybe the performance metrics. We have to take a decision. We have to have a decision that whether we need to proceed further or not. If accuracy drops below the threshold, right, model must not deploy, right? This is the metric driven gauging, right? Accuracy is below again the threshold, right? In the maybe above below the available threshold. Say we are planning to have a threshold. We have fixed a threshold of some 90%, right? If it is it has come out to maybe 80 or 85, so we have to take a call that the last model is best, right? So that also needs to be checked in this case. If you think about the software, ML, the software, uh, the ML workflow, right? Continuous integration and deployment workflow. ML pipelines are cyclical. Monitoring feeds and retraining happens. Deployment is confidential on performance. This is the key distinctions whenever if you are dealing with an ML kind of CI/CD workflow. Again, it is not a big deal, but apart from the traditional systems, right, what we have so far, right, we have to assure that the ML-enabled solutions are right. We can divide this into two parts, and we can have we could call it as right before deployment. We have taken this much of steps, right? So the testing, validation, and everything is intact, right? So again, software, if you are comparing with a software CI/CD versus ML CI/CD, yeah, me, right? So software CI validate correctness. That's all. Again, she's a rule-based correction. C is equal to A plus B, whether that works or not, right? ML CI/CD validates reliability. What is all about, whether the solution is reliable or not. Artifacts different, metrics different, the evaluation metrics are different, versioning complexity differs, right? See, again, we can't call that the final version is this, right? Again, it is depends upon the performance evaluation of the new model, right? In that case, versioning complexity differs. The distinction must be clear to everyone. So who all are using this, yeah, the distinction should be clear in the scenario. Again, to move ahead with performance threshold testing in ML, before deploying a model, accuracy must meet the threshold. Often we compare the new model with the existing production model. Only promote if it is better. In our the enforcement prediction model, we always compare the new severity model against the current baseline, right? So again, we will not move into any of the blind deployments because the data, the results should be there. Then only we can take the call, right? So this should be in place. This should be we have to be aware of it. While we are deploying, while we are dealing with the deployment. The next, while moving to the two pipelines, one goal is reliability, right? software CA, even if it is a rule-based software, again, CA ensures code works. MLCA ensures intelligence works, right? So another case is, but one more element is missing. Environment consistency is also important because again, see the software. We are not at all dealing with the intelligent engine there, right? So then we have to say that the environment consistency also matters, right? Another important, right? So as of now, we have completed about the basics, like what is the necessity, what are the types of CI/CD available, all those details, how it differs in machine learning environment and all. Another important case, another important scenario we'll have to discuss at this point in time is containerization and CI/CD automation for machine learning. What is all about containerization, right? We now say automation without consistent environment is incomplete. This is the way. This is why we need, containerization. What is all about, consistent environment? Consistent environment means, right? Say, what is a container? So we should know that what is all about a container first. The container means why we need to have a container, right? We know that. Let us think about in the inception phase, right? Whenever we have tried to deploy a web application, what was the initial step we have taken during that time, right? We have just we might have purchased a server, right? We have installed all the applications there, all the relevant application, either if it is a LAMP stack, right? So if it is a PHP enabled stack, or if it is a .NET application, if it is maybe something else, right? A Java application, all the dependencies, everything we'll have to install there as well, right? So that was actually a major trouble during that time. In the inception phase, maybe in the initial phase of our web application deployment, or maybe in the deployment application. That was whenever we are dealing, right, if something happens to that server, so the recovery mechanism itself was very tough. But there is actually an introduction of VMs, virtual machines. Virtual machines was useful for us. Actually, to deal with, maybe we can have a single server, maybe we can purchase a server. The virtual machines can be, any number of virtual machines can be configured. Again, what needed in a virtual machine, we can have different operating systems in the virtual machines, right? So again, that was very easy, right? One virtual machine is down. If we have a great snapshot of that virtual machine within no time, right? That was actually a big relief for all the administrators during that time, right? Within no time, we will be able to make the next VM up and running. But again, resource optimization is one of the major concerns in this area. So we have to assure that it is optimally optimized utilization of the resource happens. In that case, we have moved into the next level, right? Containerization. That means in virtual machine, we have to even we can have the facility to deploy any number of servers, right? Any number of VMs on a particular server, right? But operating system was required in all the VMs. Maybe a separate operating system or a similar operating system was required. Again, utilization of the resource, maybe the hardware resource was very high. Well, but again, comparatively with the server configuration, it was easy. But even though multiple there was a requirement of having multiple operating systems in all VMs. But containerization comes in means when what we can see at this point in time is we'll be making this everything as a single maybe package here, right? So all the maybe all the containers will create with the required technical requirement. That means a node application. We will complete this as a container, right? Then what happens is we can have multiple containers. The major advantage is we don't require any independent operating system. So again, in a single operating system, in a single parent operating system, we will be able to run any number of containers there. So, so that is the relevance. That is the relevance of containers here, right? Say you'll be knowing that this is the deployment problem we have. See, whenever if you are mentioning about deployment problem, there is a classic dialogue by the developers, right? It works on my machine, right? Every yeah, see, yeah, everywhere, especially in the scenario of ML, the very frequently we'll be able to hear this, right? Different operating system, different dependency applications, different library versions. See again, deploy GPU models, and everything is different, right? So see what is containerization here is. See, containerization packages, as we said, it creates a package, code, dependencies, runtime, all the layers will be there in a container, right? So this will be right in a runtime environment. We can have the binary spec of the same. This will be into one portable unit, right? This eliminates the environment drift permanently, right? So again, containerization is that much simple, right? So we will have our code dependencies and all the maybe drivers, maybe runtime, maybe OS layer, and everything will be there as in that particular container, right? Another requirement is, let us assume that this container is available means this will be helpful for us to assure the scalability of that particular container, right? Scalability of that particular container. Say in a standalone system, right? So if even resource management can be effectively managed with the help of such containers, right? So we can manage this with this maybe a particular container. We'll discuss this again, right? With the help of Docker. You know what is a Docker here? Is a containers are maybe the typical our code dependencies and everything is available in a container, right? So we can say that the collection of our containers, maybe one of the collect maybe methods, right? It acts as a rammer, it acts as a cover, right? Will be useful for us to manage the act as a what is it? To manage containers. We can have a number of containers inside our Docker. Docker file will be helpful for us to define, right? This is one of the methods, right? So images are built and container is running instance, right? A live running instance of an image will be available. We can make it available, especially in our Docker, right? The custom n number of containers can be clubbed into a particular maybe a file, right? So that will be that will be sufficient enough for us to make it available to the next stage, right? So what is the workflow of Docker, right? So define, build, push, and deploy. right? Define, build, push, and deploy. We deploy interfaces, API as Docker containers that guarantee the consistency across environments. The connectivity, the API connects will establish in between, and we can have the perfect flow of connection here. Say, think about the Docker workflow. Docker provides the reproducibility, consistency, portability, scalability, right? So if we have if a Docker image is available, right? So let us assume that we have created for a particular maybe a task. If you want to differentiate your front end and back end activities, in the sense, let us think not your UI UX and your core business logic layer, but let us assume that in a university gateway, if you wanted to the public interacting system and the administration system, if you wanted to segregate, right? So the optimal resource utilization with the help of Docker enablement is possible with this kind of deployment style, right? For scaling inference in real-time dashboard, containers are essential for us to move, right? So again, say while we are moving into the GitHub actions, as you might have seen yesterday, right? So GitHub actions, ML workflow, and all, right? So again, we know that push, test, train, evaluate, and everything comes in. In this case, GitHub actions is event-driven automation. Push triggers workflow. YAML file defines the pipeline. No external interface server needed for us. So these all are the functionalities available at this point in time, right? Again, while we are moving into the Git hub actions, ML workflow, right? We know that this much of results are required for us. Push, test, train, evaluate, build a Docker image, and we can go for deployment. Each step is auditable. That means we can have a proper track. Failures stop pipeline early, right? This protects the production systems. So this is the workflow or what can be assured, right? So while we are thinking about the completion of the ML automation architecture, say this is the full loop. Developer commits the code. GitHub triggers the CI channel. Model claims and validates. Docker packages it. Monitor tracks the performance, right? Retraining triggers automatically. This is the production grade ML. This ML ops maturity, right? So again, we should say that see in a particular environment, the key takeaway: automation plus containers, right? Automation plus container will provide a reliable ML system to us, right? Or say CI/CD gives discipline, Docker gives consistency of our application, monitoring gives the auditability or the assurance to the sustainable environment. MLOps is not about tools; it is about engineering culture, right? So while we are moving ahead to the Q&A and all, so moreover, see at this point in time, what we could say here is again, it is not that much, maybe may not be a big term at this point in time to say, but it will be Docker plus CI/CD interface will be helpful for us to make it sure that we are on track, especially while we are dealing with or while we are into the deployment of the production ML-enabled production systems. As I see at the outset, a common understanding is required. What is the advantage of Docker or the maybe the new other facilities to manage containers, to manage the containers needs to be explored. Otherwise, from a deployment of or configuration of a single server to VMs, then containers through Dockers, right? So we can in a scalable environment that will be required, highly required for us in this ML environment, right? Again, yeah, while we are discussing these parts, say again, the second part of the session, we can have a deployment, we can have a practical check of how to deal with the deployment style and all. Right, Deepasree is here. I think you're here, Deepasree. Yeah,
Sir, am I
yeah,
audible?
yeah, you are perfectly.
Okay,
Uh,
okay, sir. So if there
yeah,
is any question, we can just state that, and
yeah,
then I will continue with the hands-on
sure.
part.
Yeah.
Well, madam, it was too technical yesterday. Uh, Today is conceptual. And it's difficult to make a question on that because we are novices or maybe total newcomers. I don't think it's easy to make a question. I'm sorry.
Yeah. Okay. So, is this new terms to you, or you are into another domain? Is that what you're coming to?
It's neither new terms nor it's a new domain, but
Okay.
the ideas rather are new. Okay.
Oh,
Uh, I haven't heard much about such exposure of
okay.
ML from this percepts.
Okay.
Okay, I can talk only about myself. About others, I can't say. This is
Okay.
the reason why I'm not able to raise a question.
Okay. I think, sir, I think you are. So you had an opportunity. Actually, have you had an opportunity to develop any ML models or anything? No.
No,
You are.
never.
No.
I am not in that direction. Okay.
Oh, okay. Okay. Yeah.
I was curious at
Yeah.
this new development of AI. At the
Okay.
time when I studied it first, it was just alien rich. Nobody else was there.
Okay.
You know who she is, right?
Yeah.
That was an
So,
ancient thing.
all right. So don't worry much. It is again, these are the features available in the domain. Say it is not that much easy to deploy a model, but once we are familiar, we can assure there is a scalable model deployed by us. Okay.
Yes.
So
Thank you.
these are all the features.
See, if I have infinite ignorance on the subject, I had to
Yeah.
admit it. Right?
Yeah.
Okay.
Thank you.
So if we have any more questions, we can take that. Maybe one or two questions. You may leave the questions in the chat. Otherwise, if you are okay with the concepts, then we can start our hands-on session. Can you just respond through chat? Okay, sir. I think they don't have any further questions, so
Yeah.
I'll just proceed with the hands-on part. So thank you, Sreekanth, sir.
Yeah. Sure. Thank you, Deepasree.
So okay. So I'm taking up from here. So we will be doing whatever sir told, all the concepts he told. We will be implementing through GitHub and also Docker. Okay. So I hope you were all able to install Docker. Docker desktop. Otherwise, please install that if you're following along with me when I'm showing you the things. If you're going to follow along with me, you can have a Docker desktop with you. Okay. Okay, so we'll be continuing from the point where we stopped yesterday. So yesterday we saw many things like what is MLOps, what is the need of MLOps, and today, yesterday we discussed how the versioning can be done for both data and for both code and data, and then we saw we deployed a Flask model, we locally run a Flask model where we gave some data to identify the iris species, and we just saw how to push it into JIT, both the recent code as well as the data. Today we will be seeing how this can be, the same JIT repository can be used as a for a continuous integration. That is, whenever we make a small change in the model, even without doing again, running again, we can just using continuous integration, we will be able to change the model in our repository. That is one part that we are going to see. Another part, as discussed, will be the containerization part, where we will be containerizing everything so that you can just transfer the machine learning model that you have built to another machine. So you may be familiar with the pickled file, and a model is pickled to save the model. But today here I am talking. Just give me a moment. So here we will be seeing. Okay. So here we will be seeing how to Dockerize it or how to containerize it. So what we basically is trying to do is, so let me just share my screen. Just give me a moment. Okay, so yesterday we saw, I hope it is visible for you. Okay, so yesterday we had a discussion on these things. So let me just start at that point itself. Okay, so yesterday we were talking about the deployment, the data drift, how to deploy the code, how to build and test the code, the code to pushing code to GitHub and pushing data to DVC. And we saw how a machine learning model is trained, all those things. Now today, so once we have made our model, yesterday we have created one file called train.py, which is basically our model. Once this is run, we get a file called model.pkl, which is the pickle file, which is the model I have built and saved. And also I created a file called app.py, which is the Flask file, which in turn use index.html to show the application. So this is the entire application so that we have created for our iris data. So yesterday we created this. And we could run it locally, like we run it in localhost /5000. So we couldn't run it in any other system, but in our local system. So this is our local system. Our system. Suppose I want to run it in another machine. Okay. Suppose I have a machine, another machine, which I want to run. I want to run the same model, the same application in that machine. In that case, I cannot just directly copy every file and run it here. Maybe the version of the software is not correct. Maybe the installations are not there in this machine. So it is easy if I could package everything like a lunchbox. Maybe I could call it a lunchbox. That is, I am packaging everything as a lunchbox and I am giving it to this another machine. So this lunchbox is called a Docker image. So Docker is a platform where it is used to package this and send it. So I can send it, or I can just send it to internet. This Docker image I can give in World Wide Web, or I can just copy it to another computer. What happens is inside this, that same image of our data, our model is created and it is easily run in this. So otherwise, if it is not containerized, what happens is we need to install the same packages as we did in the system. Both the systems should share packages, or yes, sir. Can you please ask the doubt?
You said package, right?
Yeah.
Package. So it is actually a conceptual package, right? Conceptually, you consider it as a package.
Yeah, conceptually, yes. It is actually, the thing is like taking something from one home to another. Okay. So,
it is not a physical container, but
no, it is not a physical one. It is basically a software.
Yes, exactly. That is even there. It is an idea that you actually are taking it as an ingredient of that lunchbox or that package. Many ideas being packed together in a cohesive manner, right?
The ingredients of lunchbox is all these files: train.py, app.py, index.html. All the files that we created yesterday will be packaged and will be sent to another computer. Rather than copying all these files in a pen drive and sending, the problem
that idea is clear.
Yeah.
What I said is those ingredients help each other to function, right?
Exactly. Yes.
Yes, thank you. Right.
Okay. So rather than copying these files, I can just make a Docker image. So what is the advantage is I can just run it in this new environment, even without every dependencies, every packages, every files, even the packages. For example, if I am using Pandas 2.1, I can just specify then that version will be installed inside the Docker image, and you can get the same output. So what we are going to see today is we are going to see how to containerize the application that we built yesterday. So for that, we will create a file which will contain the instructions for containerization, and we will containerize it. And maybe we can save it as a tar file, as a zip file or tar file. Then you can maybe later you can copy it and try it on a different machine. Since we cannot see that today, you can just open it in a different machine and you can try that as well. So to copy your machine learning model, or to copy your application, or to make your application run in another machine, you need this containerization. That is the best method that you can do. Okay. So let's just start in the same folder that we created yesterday. So I am taking the same folder. If you remember, this was the folder that I created yesterday. And I'm just typing CMD so that command prompt will be open in the same address. In the same location, command prompt will be open. Okay, so I have copied all the instructions needed in the file I shared yesterday. Maybe I'll copy the link once more for that file, the MLOps demo file. So I'll just share it once more. You can just open that file. So I'm sharing it in chat. Please open that file.
Opened.
Okay. Yes. Once. Yes. Sorry.
Opened. It is open. Code
Okay.
is there.
Okay. So once you open that, you can see some files like day 2, some code I have shared. So day 2 CI/CD Docker, you can see that. Okay. So the first line in that, the app.run host, the line that you can see is you have to replace it in the yesterday's file. So let me just share yesterday's file. We can just take code dot and it will open VS Code for you.
Right.
Okay, so in VS Code, if you remember, we can take the file called app.py. So in app.py, there is the last line in app.py, app.run debug equal to true. This line is used to run the Flask application locally. Okay, so I'm just going to change this. I just going to paste the code that I have given in the notebook. So this says my host address as 0.0. Again, it is local host in port 5000. So that even when sometimes what happens is when the container, now we are going to run our application inside the container, like inside the lunchbox, we are going to run the application inside the container. At that time, sometimes it may not take the previous host address. So I'm just providing a host address like 0.0, which is again the local host. Again, it is going to run in our local host, but inside the container. So that last line I just changed. So now, once it is done, as I told yesterday, autosave must be enabled, otherwise it should be saved. Now let's just go back to the command prompt. And here I am going to create a Docker file. Okay. So the Docker file is created in this location. So I'll just take the location where my folder is there. So in this location, I'm going to create a new file. You can just create a text file and then rename it. So I'm going to rename it as Docker file with no extension. There is no extension. So it will ask if you change extension, are you sure to change this? Just give yes and create a file named Docker file with no extension. Now you can just edit the file. You can just open it, edit in Notepad. The second code, the I have in the notebook that I shared, I have given Docker file. There is a heading called Docker file. You can just copy the whole content from there and copy it to this file. So you can just see the content here. Just let's just understand the content here. You can just copy and listen here. So this is what I told you to copy. So we are going to take the working directory. From the working directory, we are going to copy everything. And whenever this need to be, so we are going to copy the entire file here to the new container. And whenever this is run, we need to run pip install -r requirement.txt. You may be remembering yesterday we did this manually. We did this pip install requirement.txt. All the required packages or libraries were written in requirement.txt, and we just run this manually. So now instead of that, I am giving in Docker file that we need to run this first. So first this must be run. After that, we should run Python app.py. So once you run Python app.py, you know the application will be run. So I am giving instructions through Docker first to in any system. Whenever this Docker file is opened in any system, the requirement.txt should be run first, then Python app.py should be run next. So what happens whenever I am copying this Docker file to any system, all these things automatically happen inside that. Once I run the Docker image, all these things will internally happen. I need not run it manually. So yesterday we did all these things manually. Rather than that, I am just keeping a Docker file which instructs when the Docker image is executed, this should automatically happen. Two things should automatically happen. One, installation of the requirement.txt, and then running of app.py file. So I hope you have copied this, saved this, and now you can close this. Okay, so now in my shared folder, you can see there is a file called Docker file. So this Docker file contains all the instructions that are needed. So if you need more instructions, if you want to run the train.py also, we can just add those instructions in the Docker file. Whatever you want the system to do when this application is, when you want to host the application, what are the prerequisites, what are the dependencies there, you can just tell that and you can just run that Docker file. So I hope you are all following, you are all able to do till here, right? Okay. Now I am going back to my command prompt. So inside this command prompt, I'll just build the Docker file first. Okay. So from the base environment, I copied the project files. I wanted to install the libraries and start the app. So that I'm going to do inside this. So if you remember yesterday, we did all these things from VS Code. So now we are going to do it inside the Docker. So if you have installed the Docker successfully, you will be able to get this. Just type docker version. It should show this. That means your Docker has been installed successfully. So the instruction to build Docker is again given inside the file docker build minus -t. So to build the Docker image, I have given the instruction inside the notebook. So you can just copy that and paste it here. It is docker build -t. So Iris ML app is the name that is given, and dot means it is here. In all the files are here in this current folder. So I'm just going to build it, and the image of the image name of the Docker image name will be Iris ML app. So once I run this, it will take some time. Building will take some time because it is copying. It is just creating a Docker image. So you can see it is all the requirements, all the files, all the libraries and the requirements are getting installed. All these things are happening. Okay, so I take some time. It will take because a lot of dependencies are there. So it is just building with all those dependencies. So once this is built, then we will be able to run it in our local system, but through Docker. So once this is done, we will be running the Docker image rather than the one which we created with VS Code. We will be running a Docker image. If you have any question, feel free to ask. Any doubts?
Hello.
Yes, yes.
Yes, ma'am. I was doing the step. The error occurred here, saying could not open requirements file. I mean, no such file or directory named requirements.txt. So is it
So did,
mandate to
so
make
did you make a requirement.txt last day, yesterday?
Oh, okay. No, 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 no. Okay. Oh, that was issue there.
Yes, yes. Yesterday, if you
Okay.
remember, we made a file called requirement.txt, which had all the
Requirements.
requirements, right? So
Okay. Okay.
that's
Yeah.
so
Okay.
Docker is searching for that file because we have specifically told to pip, we have given an instruction like this: run pip install -r requirement.txt. So that's why it is searching for that file.
Okay. Okay.
So
Okay.
if
Yeah,
you
good.
want
I
to
got.
run it without that, you can just remove that line from the Docker file,
Okay.
or you
Okay.
can create a requirement.txt.
Okay, ma'am. Yeah. Thank you.
Okay, so now our build is finished. That means our image is stored in Docker file. So to show images created, again, the step I have given, please follow the steps I have given in the notebook. So if you just click on write Docker images, you can see in my repository, I have two images. This is the image that I created, Iris ML app, and this is another image of another application named N-Item. So which I installed like 3 months ago. Which I so you can also do that. Any applications if you run online, most of them have the Docker images. You can just download the Docker image and you can run it locally. So like that, I installed that 3 months ago. So this is the new image that I created, Iris ML app. It is latest. It was created a minute ago. You can see it is of 2.67 GB. So everything, my machine learning model, my application, my pickle file, everything is inside this Docker image right now. Now I can just pass this Docker image, or I can just run my application using this Docker image. So you can see as the next step in my document, I have given a command to run the Docker file from this. Okay, so you can just run our application through container. Now the application is running through container rather than yesterday we saw it running from VS Code. Now it is running through. So you can see running on HTTP 127.0.0.15000. If you click on that link, you can just do control click. You can see my application, which I created yesterday, as come again. Okay, I can just give some value to sepal length, sepal width, petal length, and petal width. It will predict which species is this. So you can see it was the same application that I created yesterday. The difference is yesterday we run it through VS Code, but today we did containerization and we run the Docker image rather than running. So what happened? The Docker, I didn't install the requirement.txt. I didn't do Python app.py like that. I just run the Docker image, and Docker image gave me the application. I hope the concept is clear for all of you. If you have any question, please feel free to ask. Anything? Were you able to do this?
So, ma'am, this
Yes, sir, I couldn't hear you.
is it audible now?
Yes, yes.
Yeah, this container, once we started, it will persist, right? It will be there.
Yeah, until, see, now it is running. Okay. If you want to stop it, just press Control C, it will be stopped. Now it is stopped.
Okay.
So until it is running, you can access your application.
So next time, if we want to
Sorry, if you want to,
start this again,
you just have to run like this again. Docker run -p 5000. Just run that again, it will run. So you can just click on this link and you can again take the application.
okay. This time that package installation and all not needed.
No. It happens only at the time of build.
Oh,
At the
okay.
time of build, it is installing every packages and everything. And then at runtime, it just runs. So anytime when you give a new package, like when you pass this to a new computer, you are opening this in another system, the same Docker image, you have to build it first and then run it. So at the time of build, everything will be installed, and after that you can just run that application, any application. So if you go to internet and search, you can see Docker image of many applications which we can run locally.
Oh, okay, okay. And suppose we restarting our machine, that time we need to start from scratch.
No, you just have to build once you restart the machine, you can just build and run anytime.
So build needed, right?
Yes, 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 yes.
Oh, okay. And related with its compute storage and all, it's from local picking, right?
Yes, it
We
is. Yes, from local only.
we can do any customization on that 50% of compute something.
Uh, sorry, I didn't get the question.
It's like suppose 100 is our compute capacity. 50%
Okay.
of that we can
Okay.
allocate.
Using Docker, yes, it is possible, but I think you need Kubernetes for that. Like you can just allocate various pods, and you can just give like storage capacity as well as a computing power. You can just divide that.
Okay, thank you.
So one thing one thing, sir, I wanted to clear, that is, once you load it to a new system, you need not build it, you just need to run it. Okay, so building is only required when you want to create the image. So the question you asked earlier, Jen, sir.
Yeah, got it. Yes.
Okay. So when in a new environment, you just load the Docker and you just run it. Build is needed only when you want to create a new image.
Sure, got it. Thanks for the call.
Okay. So if you want to store this, suppose if you want to store this as a, let's say we want to zip that and store it, you can just, so I'm just stopping this, and you can just try this. Okay, so Docker save Iris ML app 2, I'm just saving it to a tar file here. And once this is complete, you can see in your folder the tar file is there, which you can just copy and pass it to another environment where you can just load it and run it. The only thing is, in that system also Docker should be there. So any applications you can just copy like this. You can containerize and pass it on. So now if you check the folder, you can see the tar file has appeared here. So this is the Docker image, which is compressed to a tar file. So I'm just deleting this for now because I want to do the continuous integration part in the same folder. So I will be doing it with the same repository that we did yesterday. So if you are all ready, we can move on to the second part of the session, the continuous integration. If this part is clear, if you don't have any question, or if you're able to, we'll move on to the second part. Okay, so the second part, so I hope it is clear for all of you, containerization. So the second part, as Sreekanth sir explained, it is the continuous integration and continuous deployment. Okay, so let me just explain what we are going to do. So here, I am going to in continuous integration. So you know that whenever I make, so as you already know, we have these files train.py, which when I run creates model.picker. So suppose I want to change something in train.py, I want to add something, or I want to change the algorithm. So after some time, so if you remember yesterday, there may be many problems with the running machine learning application. The data drift may occur. We need to retrain the model. So every time when there is a change in the train.py, we need to call Python train.py, recreate the model.pickle, and upload it when we use it as the new model. All these things should be done. So what happens in a production environment, especially in a industry scenario, this changes may occur multiple times before a release, or before a sprint, or before a particular time, before a new product is released. This has to be done continuously. So this is called continuous integration. So what we need to do is, whenever a change occur in train.py, even without, so manually what we need to do, when there is a change in train.py, we need to call Python train.py, create model.pickle, again push it to the GitHub as a new version. So again, next time when a change occur in train.py, we need to create model.pickle, we need to push it to the Git. Like that, this process need to be done manually. So what we are trying to do in continuous integration is, we will just, whenever there is a change in train.py, we don't do anything, we don't build, we don't run or anything. Whenever there is a change in any file, any associated, for example, in our case, if there is a change in, we will just push it to the Git, and inside Git through Git actions, automatically this will be trained. The training will be happening. The model dot, it will create the new model dot pickle, and it will be storing it in a place that we see. So what happens here, you need not do all these things every time. So you know the training may take hours sometimes. Yesterday we just trained a very small data, only 143 rows of data was there. But when we are doing a very big model, maybe with images and all, it will take a lot of time. The training itself, it takes a lot of time and computing power. So what happens, whenever I do a small change in train.py, I need to change this model.pickle, and it takes a lot of time, and then I need to push it to Git. So it is like manually we have to do all these things. But the Git has a feature called actions, which allow you to do this automatically. That is called continuous integration. So what happens, whenever there is a change in train.py or any associated file, you just push it in the Git, and we will give instructions through actions that whenever this push happens, whenever they push this file, you automatically just run this file. Just run python.train.py and create a new model.pickle. Every time I push it, automatically inside Git, it will do all these things. We need not bother about training the model again and again. So this part is how we are going to implement the CI/CD part. Is the concept clear for all of you? Any question in this? Clear what we are going to do? If you have any question, I can answer, and then we will move on to the hands-on part. Can you please respond Is it okay? Okay. Yes, I hope you got the concept of what we are going to try. So let us just, again, I will just take my command prompt. Okay, so I took my command prompt. So here you can see I'm going to create a file here. So again, I have put that in the notebook. You can just look. So in the notebook that I shared, I have given, you can see after save the Docker image, you can see CI/CD. Inside that, I have given 3 commands. So please copy that. We can first create a hidden folder called GitHub. Then open GitHub. CD is for opening GitHub. So we are inside that folder .github, and inside which I am just creating a folder called workflows. So inside this workflows, I will be creating a YAML file which has all the instructions needed for continuous integration. Okay. So you can see after this, you can see a workflow file there. So let me just, you can just copy that workflow file and we will go to the folder. So in this folder, you can see a new folder has been created named .github. Open it, inside which there is a folder called workflows. Open that. Take a new text document where I am going to name it so you can please go to the file, go to .github, inside go inside workflow, inside which I will be creating this YAML file. So it will be a file with extension YAML. Okay, so you can name it as ML pipeline. So here I am going to name it as ML pipeline dot YAML. So again, it will ask, are you sure to change? It's okay. You can just change that. So not YAML, YML, sorry. YML. Rename it as YML. We can just open it. Either you can open it in VS Code or you can just open here. Paste the content that you copied. Paste the content. So this is the content that you copied. So I am going to say the name of this YML file is Iris ML CI pipeline, continuous integration pipeline. So I am going to, when on push, on what action, whenever a push happens, to which branch? To main. So if you remember, yesterday we created a branch named main, and inside which we pushed everything. So I'm just telling the action on which this should happen. So whenever a push happen, on a push happening to this branches, what all things need to be done? So a build should be run. So we will check out the repository. So in actions, we check out the repository. We set up the Python for that because we are going to run it in Python version 3.10. So install all the dependencies. So here, if you have, I have made a change here, because if your file name is requirements.txt, you have tried that. In the code which I shared, it is written as requirements.txt. if your file name is requirement.txt, please replace that. Okay. In the code that I shared, it is requirements. I have written requirements, but in my case, it is requirements. So I changed it here. You can also do that. So we are installing all the dependencies. It is telling to install -r requirement.txt and then run the training script, because we are going to retrain the model. So we need to run the training script. And once, so it is checking, verify model exists. If once the Python train.py executes, the model should appear, right? The model should be created. So using a if condition, if model.pickle is not created, if a file in that name doesn't exist, it will echo a message called model not created. It will print a message like that, and it will exit with code 1. So code 1 indicates that there is some error. Otherwise, if this is not the case, we can just upload the model artifact. What is the model artifact? We are just uploading model.pickle, the new trained model, the new model with the changes, that is model.pickle. So what is the advantage? Instead of manually running this, whenever you make a change, you just make a change in train.py, you can just push it and it will automatically run and the model will be created. So you need not worry how much time it takes. Everything will happen automatically. So this is called continuous integration. Okay. So just save it. Save it. Just remember, if your file name is requirements.txt, please change it. Whatever is your file name, please change it like that. Okay. So I stored it as my ML pipeline.yml. Now again, I will take my control CMD, the command prompt. So now I am going to push the contents. So I'm telling git. So I need to go back. Okay. So I'm going cd ... And I'm telling, because I in the base folder, right? You okay? This is my base folder. So I'm standing here in the base folder, because earlier I was in .github. I just went back using cd ... and inside this folder, UOKFDP, I will just type as we did yesterday, git add dot, and after that, so once you add, then you can tell what commit you are going to make. You can name that commit. So in that name, you will create an action. Okay. So in that name, there will be action created. Okay. So we will just, the second code I have shared with you, you can just copy that. It says git commit -m add CA pipeline. So git commit -m add CA pipeline. So it did all the insertions. So 2 files were changed and 2 insertions were done. And I will do the git push as we did yesterday. Once you do the git push, you just take your GitHub. Okay. Just take your GitHub page and see. Take the GitHub page. Inside there is a tab called actions. And you can see a new action has been created here and it is running. Okay. So if everything is done correctly, you will see a yellow dot telling that it is running. Otherwise, if there is an error, it will show a red cross here. If you have any error, it will show a red cross. Otherwise, if you have done everything correctly, it will show a yellow dot. So it is running. So you can see the build. If you open that, you can see it is doing all these things, installing the dependencies. So set up the job, check out the repository. It is running the training script. So you can see it has completed successfully. The build has completed successfully. It says it's the model trained with accuracy 0.666, and it says every post job cleanup, everything is done. Okay, and the model artifact has been uploaded. If you want to download the new model, you can see it is available in this repository in GitHub. The new artifact, the new model, the one with we developed as the continuous integration part has been uploaded here, right? So anytime I make a change in the model, I can just do this. It will run again. This can be run and the model will be stored. Okay, so if I go to actions, you can see in this, when I go down, you can see the artifact, the trained model is stored here. Okay, suppose I'm just changing, suppose now what, like, let's just see. I'm going to change in my model. I want to change something. So app.py in train.py, actually the train.py here, I'm just changing, say, after after doing all the ML flow yesterday, we did all the ML flow and found out which is the best parameter. So suppose I found that the best parameter is 300. So I will just put 300 here. So I made a change here. So I'm not trying to, if it were in the manual form, I need to build the model here again and see, but I'm not going to do that. I am doing as part of continuous integration. I'll just push this code and let's see what happens. Okay, so I'm just going to push this code. I'll do again, I will just zip.add and I'll just commit the CI pipeline. Just let me give you as pipeline 2. So one file changed, one in session. You know, I changed in the train file, right? So I'll just do zip.push. At that time, you can just go and see my GitHub page. See what happens there. So in my actions, a new pipeline, add CI pipeline 2 has been added, a new action. So I can just see the build, how is it going? So it is installing all the dependencies. It is running the training script. So it will run the training script. If everything is done correctly, it will run the training script. And if you remember, the earlier run gave me an accuracy of 0.66. Now I have changed the model. So it is running python.py. And you can see here clearly, now it is, the model is trained with accuracy 1.0. Okay, so I changed the model. The retraining part was done using continuous integration through GitHub Actions. So I got the accuracy of 1.
Excuse me, ma'am.
Yes.
I am having issues with git push. While giving git push, an error is coming like no configured push destination.
Okay, did you do that origin main branch origin, that thing? Did you do that?
Actually, no, ma'am. We didn't get any notes of that. So yeah, I couldn't do that.
Okay. So maybe I will do one thing. As I told you yesterday, I will give you the detailed note. Then you can try it again, because you had to do that. You had to create a branch there. Then only you will be able to push it.
Okay.
Okay. So without creating a branch, you will not be able to push. So let me see if I have that code with me.
Yeah,
Just
can you share that code today itself? Can you?
yes.
Okay.
You just want that code or the entire thing?
I mean, basically related to Git. Notes related to Git.
I will just give you now. Okay, just a minute.
Okay.
Ma'am, this build happening in local machine, right?
Yeah. No,
Is
here,
it possible? Yeah,
this one, it is happening in JIT.
JIT
In
only. Okay.
local machine, yes. And it is not happening in local machine. That is why
Okay.
it is called continuous integration. We are trying to continuously integrate through GitHub Actions.
Okay. After this deployment, also we can automate, right? To
Yes,
a trainer.
yes. We can do that. So, Parvati, I'm just sharing through chat the code. So here, the repo URL, you should give the repo URL. If you remember, we copied the repo URL yesterday. Do you know how to take that?
Actually, no, ma'am.
Okay, so just give me a moment. Okay. So once you take this, once you create a new repository, so I'll just show you how to do that. So you can create a new repository first, give some name to the repository, and you can decide whether it need to be public, and you just create the repository. And then this is the URL. This is your URL. Okay, just copy that, and in your CMD, you have installed JIT, right?
Yes, ma'am. Yes, ma'am.
Okay. So then inside the CMD, so in the command that I give you, git remote add origin, you paste this URL. And then you try pushing. Okay.
Okay, ma'am. Yeah, I'll try that.
Okay, fine. Okay. So I was telling you about actions, right? So here, in this repository, I have not created any action. So it says get started with actions. So my actions was created in the repository MLOps. So in my two times I run this. If you want, you can just add to the same branch, or you can create a new branch, and you can do this continuously. Whenever there is a change in the train, you can just push it, and automatically it will create the new model.pkl, and you can use the new model.pkl for your applications. So this is how you do implement the continuous integration. Okay, so today we saw two main concepts. One was containerization and another was continuous integration. So containerization is used to package your application so that it can be hosted, either it can be hosted or it can be passed on to another place without affecting environment. It like if one system has an old Python version, but the system in which you developed, so you cannot say like this application run only in my system. That is the thing we always face, right? We developed an application, but because of the dependencies of the packages that we have installed, it run fine in my system, but when I give it to another system, it doesn't run. So it is not easy to install every package like your system, the same environment. So the solution is Docker. You just containerize it and give the Docker image to another system, so that in another system you can run it easily. All the dependencies, everything will be handled by Docker. That is one thing that we saw. Second thing that we saw was continuous integration, where in continuous integration, whenever a change is made in the local system, we can just push it to JIT, and through GitHub action, it will be integrated and the new model.pickle file will be created. So, in industry, there may be multiple people working in same project, and multiple people will be doing changes in the same file. So in that case, they will have their own branches. They will be continuously integrating to their branch and creating new model files. So even though the training part takes a lot of time, that will happen in background. They need not worry about how long it will take for modeling. JIT actions will handle that. So that's all I wanted to talk about today and show you. And I hope you got an idea at least, even if you were not able to follow along with me. I will share a file containing all these instructions, everything. You can just go through that and repeat this process. At least I hope you are able to understand the concept what we were trying to explain. So as I told yesterday, since there are participants who are new to machine learning, this some of the jargons may not be familiar, but once you get to do reading about this, then you will get understanding. So you can start building a machine learning model. Now you have the first machine learning model with you, the iris model. You have that with you. You can just take it as a starting point, and you can start building. So that's all from my side. If you have any question, I'll be happy to answer anything you want to ask me, and any questions regarding this. Any questions or any comments?
Dear participants, if you have any questions, you can either message or ask to ma'am.
Okay. So I think we are all good. So in that case,
Yes, ma'am.
tomorrow you will see how to deploy this, like how to publicly deploy the thing to a platform. So as you know, we can deploy it through cloud, like through Amazon, Google, or any cloud services. But since they are all like we have a very few amount as free tier, we will be showing doing a demo through some free platform. But the process is almost similar. Even though it is a free platform, you can do the same thing in Amazon or Google, so where you can host your application. So in that case, they will charge you if you want to host your application. So this kind of free applications, free hosting websites give you a few limit, where few free tier where we can host it. So tomorrow you will be seeing about that, and I hope the sessions will be useful for you. And thank you so much. Thank you all for the patient listening. And I hope those who were doing hands-on along with me were able to complete. If you have any question, you can just give it as a mail, and I'll be happy to answer those. Thank you.